this session we are going to start the new chapter, which is chapter number 10, circles. You have already studied this in grade 9, but this year we are going to study something new. So far we learned that parts of a circle we already learning since grade 6 and 7 as well, right? Then last year we learned about the chord, how to measure the chord. Then we proved some relation with the help of quadrilaterals and congruency of triangles, right? This year we are going to learn about tangent of circle. What are the properties? What are some theorems? How to solve sums with the help of it? So that is our chapter circle. Before we move on, let's discuss few basic terms that we already know about circles. So we know circle looks something like this, and most important thing it has, which is center. And most unique thing about circle comparative to all shapes is that you take from center to any point on the circle, that distance is going to remain same. That is the unique property of the circle. Right, from center you start and you take any point on the circle, that distance is going to remain same, and that distance is called is what? Radius. We all know that, radius. We even know that how to find the area of the circle by this time, right? Next is about the diameter. So let's say you connect 2 points of a circle and that line should be passing from the center. Let's say this is it. So I'm taking this one and this is it. Right, so this is called as a diameter of a circle. You can see that radius is coming 2 times, radius here and radius here as well. So we are connecting 2 points, yes, but what is the mandatory condition? That line should pass from the center, very important. Then it is called as diameter. Now let's talk about if that line is not passing from the center, then what do we call it? Yes, chord. We learned about that in last year. So let's take it chord. I connect any 2 point on a circle, any 2 point you can take it. Maybe it can pass from the center or maybe it cannot. It's all fine. Let's say this is the center of the circle and this is the chord, right? It starts on the circle and it ends on the circle. Remember, there is one more term we are going to learn with reference to line and the circle. So remember, when we talk about the chord, it starts on the circle and ends on the circle, right? Okay, so we know what is chord. Let's label that it is chord. Now you can see that circle is divided into 2 parts. Upper kind of not even exactly half, it is more than half, and this is lower half, not half, less than half. So this particular area is called as segment. Remember, segment. Now it is the smaller one, so it is minor. If there is minor, there will be major as well. So this is major segment and this is the minor segment. Very basic terms, we already are aware about this. So when you draw the chord in a circle, circle will be divided into 2 segments. Bigger one is a major segment, smaller one is the minor segment. Let's talk about the next term, arc of a circle. Arc of a circle you can say as it's a piece of a circle. We just talk about this curve part, right? When you break the bangle, that is arc of a circle. You will be getting pieces and those pieces are considered as arc of a circle. Remember, so again let's name it. Let's say A and B. Here in middle I am saying C and here D. So again there are 2 parts like major and minor. This ACB arc, let's say ACB, and this is a symbol, you are already aware of it, discussed in grade 9. So this is the minor one. So minor arc. Done. And let's talk about the major. Major will be ADB. So ADB, that is major arc. Simple. So that's about the arc. Let's learn about the one more important term, and we are going to discuss in the next chapter as well, finding the area, which is the sector. Let's say you have a cake and you are cutting a part of it from the center. So that is called as a sector of a circle. Now what is a good thing? What are the parts of a sector that we need to learn? See, this is the radius. So it is bounded by the radius. Okay. This is radius. This is also radius. And can you observe one more thing? Yes, this is arc. So when we talk about sector, there are 2 radius and 1 arc. You can say that as arc. Let's highlight it. So this is what sector. In next chapter, we are going to learn about how to find the area of the sector for specific angle as well. So these are the basic terms, which is center, radius, diameter, chord, major segment, minor segment, then arc, major and minor, and the sector. Let's learn about new thing that we are going to discuss this year. First of all, we are going to discuss what are the different cases when we talk about a line and a circle is possible. Either it is inside, either it is on the circle, or either it is outside. And we are going to learn about one very important term, which is tangent. I told you. So let's start with that one. Let's discuss the topic that we are going to learn in grade 10, which is tangent. You must be thinking, what is that? We learned this word in trigonometric ratios, right? Tangent, cotangent, right? It's somewhat related, but not exactly. You are not going to learn this year how they are related even. So before we start discussing the word about tangent, let's discuss few concepts first. Okay, I have one line which is PQ, another I have circle. With center, anything you can say, A, O, B, C, anything will work. So there are 3 possible cases when we talk about line and the circle. Either line will be outside of a circle. In that case, there will be no common point between line and this circle. Simple case. Okay, line is outside of the circle, so obviously there is no intersecting point. We need to think of the intersecting point, right? So there is no common point between them. Done. This is the first case when the line is outside the circle. Now let's talk about when line is inside the circle, right? So you must be thinking that this looks like something chord, right? I told you that we will discuss one more word that is related to chord, but not exactly chord. Okay, so this is the case. So first of all, we have line which is inside the circle. So you can see there are 2 intersecting points or 2 common points, which is point A and point B, right? Now this case is called as a secant. Okay, let me write here, which is secant. And what is the special thing about secant? And why is it different from the chord? When we talk about the chord, starting point is on the circle and ending point is also on the circle. But when you see the secant, starting point is not on the circle, right? And ending point is also not on the circle. This is the difference between secant and chord. Remember, so this is the case where line lies inside the circle. There will be 2 intersecting points or 2 common points. Now let's talk about when line touches the circle. It only touches circle. That's it, nothing else. It's not even going inside the circle, not outside. It just touches the circle. In that case, there will be only one common point, right? And that line is called as a tangent. This is what we are going to discuss this year. This is the case that we are going to talk again and again. We are going to prove results related to it, theorems related to it, and we are going to do numericals based on it, right? So this is the case when line is touching circle and there is only one common point. We are going to talk with the case only one common point. No common point, it doesn't make any sense to discuss anything because there is nothing common. What will you discuss? Line is straight, circle is circle? No, right? Second, that is a different case. We are not discussing. You'll have in higher grades how to deal with it. But this one common point is the interesting case that we are going to discuss this year. Let's learn about tangent. Let's discuss few points related to tangent. First of all, let's start with the name. What does this mean? What does this name tangent mean? It is from the Latin word which is tanger. It means that to touch, and this name was identified by Danish mathematician which is Thomas Fink in around 1500, right? So this is a small history of it. We are not going to discuss and nobody is going to ask you in exam, right? Let's learn few properties of the tangent. So I have drawn the same tangent which is over here for another purpose. Let's start with the properties. It intersects circle at only one point. Remember, if I am drawing one tangent, it will touch at only one point. It is not possible that this tangent can touch on many points, right? One tangent, one point. Next, special case of secant, when 2 points meet. Now what does it mean? Why are we relating with the secant? So secant, I told you that it is a case where line is inside the circle. Now see, in case of secant there are 2 points, point A and point B. It is written special case of secant when 2 points meet. So there are 2 points A and B. We want that to meet. So what will happen? This point, see, if I draw this secant over here, the distance is decreasing. Initially this was the distance, now it is decreasing. Let's draw this third line, right? So distance is decreasing. So there will be one point that there is no distance between A and B, means they will meet. So that case is what? Tangent. This is what it means when it is written that special case of secant when 2 points meet. These 2 points are going to meet, right? That is tangent. There is only one tangent from a point on a circle. So this is similar to the first one, right? If I take any point on the circle and if I want to draw the tangent, how many tangents are possible? This is what it means. If I am taking one point, there will be exactly only one tangent. It is not possible that you can draw infinitely many tangents or more than one tangents. One point, one tangent. That's it. No need to discuss. There can be maximum only 2 parallel tangents to a circle. Right? Now this is the same case because let's say this is the circle, and when you draw the diameter, let's say this is the diameter. So another tangent which is parallel to this one will be passing from this point, right? So there can be only 2 tangents parallel to each other at a time. It is not possible there can be third one. If you are trying to draw inside the circle, that will be the case of secant, right? Remember, so these are the few important points that we need to remember. Now let's come to length of the tangent. Let's say I'm taking, this is the point P, okay, contact point. I'm taking this point Q, right? So specific line segment from a line is called as a length of the segment. Let's say this is here and here. Let's name it as O, right? You can connect OP as well, OQ as well. We are going to learn in the theorem how to do that one, right? So this PQ is called length of the segment, length of the tangent, not the segment. So it is always specified that this is the length of the tangent. We don't need to calculate from what point it is starting. Most of the times the figures will be given regarding to these chapters in exam, right? If it is not given, there will be formation of the words in a manner that you can understand in easy way, right? So this is about the tangent. Remember, there are 3 possible cases: line outside the circle, no intersecting point, no common points. Line inside the circle, there are 2 common points. It is called secant. If line is on the circle, which is only touching it at only one point, that is what? Tangent. That's what we are going to discuss. So these are the 4 properties of the tangent that we need to remember. Let's move on to the next topic, which is proving the theorem related to tangent. Let's discuss first theorem of this chapter, which is the property of tangent. Let's read the sentence first. The tangent at any point on a circle is perpendicular to the radius through the point of contact. Okay, so there are many words we need to understand piece by piece. Okay, so the tangent at any point on a circle. So we have tangent, right? XY is a line. Then on a circle is perpendicular. So we need to prove that it is 90 degree. How? Perpendicular to the radius, right? So this is the radius. OP is the radius, O is the center, through the point of contact. Okay, so point of contact, radius, tangent, perpendicular. These are the words which is being used in the first theorem. Let's learn one by one. So first of all, let's start what informations do we have, which is already given into the theorem. So let's start with the given. What's given? We have circle with center O. So circle with center O, and what's that? Tangent XY. Tangent XY. Done. So we have circle and we have tangent. That's it. Now what we need to prove. Remember, please write all these informations, because when this kind of questions are being asked in exam, it is half mark to write given and half marks to write prove. Then rest of the marks contain about the steps you are proving. Let's write what we need to prove. So to prove, we need to prove that okay, OP and PQ is perpendicular. Why OP? Because OP is the radius. Remember, this is the radius of the circle. Let's label radius. This is the radius of the circle, and P is the point of contact between circle and tangent. P is the point of contact. Now what we need to prove? We need to prove that perpendicular to the radius through the point of contact, right? It should be perpendicular. So radius is OP and it should be perpendicular to what? PQ. Done? This is what we need to prove. Now how shall we prove? First of all, right, let's think about it. We have radius OP, we have tangent which is PQ, length of the tangent is PQ. Now before I start, I want to compare the length of OP and length of OQ. For that, I'm going to give this point as A, right? So first of all, let's write OP is equal to radius. Okay, it is radius. Is there any another radius you can see over here? Yes, OA. So OA is also radius. Done? Now let's write one equation for OQ. Why for OQ? I'll tell you. We want to compare the length of OP and OQ. So for OQ, can I write that OA plus AQ? OA plus AQ, right? So what is the meaning of this equation? OA, you already know that it is radius. So length of OQ is more than OP. So this is my conclusion. OQ greater than OP. Done? Simple. For the point P, I have proved that length of OQ is more than OP. Right. Now try to take the another point on the tangent. Let's say if you are taking this point, and let's say if you are connecting with this center. Just an example. Let's say this is point M and this point B. Now, can I write the same relation for that as well? I'm just writing for the purpose of understanding. After this, you can write a conclusion and your theorem is done, right? That OP is the shortest distance. Now, if I do for the OM, right? OM is equal to, can I write radius? Radius is what? OB, right? OB is the radius plus BM. So OB plus BM. Here I can write that this is radius. So this is the another point on tangent other than P. I'm not taking P. I'm taking any other point than P. So here also I'm getting the same conclusion that OM is greater than OP. So what is my conclusion when I see these two equations? That OP is the shortest distance. OP is the shortest distance between center and the point on the tangent. Between center and point on the tangent. This is the conclusion. Tangent, right? So OP is the shortest distance. Now remember, shortest distance is always perpendicular. When you talk about any 2 points, shortest distance will always be perpendicular. Then that's the reason that it will make 90 degrees, right? So I can finally write that what we need to prove, OP perpendicular what? PQ, right? This is the shortest distance perpendicular to what? Which is PQ or XY as well. Let's repeat one more time. What information is with us? First of all, circle with center O and tangent XY or PQ also. You can write it. What we need to prove? That angle between OP and PQ or XY should be 90 degree. So what did I do? I compared the length of OP with any point on the tangent, First I have taken point Q. So I can write one equation for OQ, which is OA plus AQ. OA is what? Radius. You are adding more number into radius. So value of OQ will be more than OP because that is only radius. This is radius plus some extra. So OQ is obviously greater than OP. I've taken another point. Let's talk about another point if this first point is not working. So point M. Let's try with that one. So OB plus BM. Again OB is the radius and you are still adding something extra BM, right? So that is also greater than OP. So we proved with this 2 points that OP is the shortest distance possible from the center to the tangent, and shortest distance is always perpendicular. So this is how we prove that tangent at any point on circle is perpendicular to the radius through the point of contact through P only, not any other point, right? Because they will be greater than OP or greater than radius.